All right, so I also made like a little test repo, which is going to be like the scaffold, was a sort of scaffold in me preparing for this. Some of you might have seen it, doesn't matter if you haven't. It's called Flume intro, I think. So if you like to read, if you want to like run ahead and have a look at the code that I'm going to be building something similar to, there is this repo at mix/flume intro, and particularly there's a branch called dry run. That's just me messing around with some code, trying to figure out a good example. These notes will get fleshed out, and the final version will be on the master branch. So, cool. Well, I might start by drawing a diagram and showing you where this, to talk about how flumeDb works. This repo is actually really good. I just happen to like diagrams as well. Why not? Okay. So what's nice about Flume's architecture is it's got all of these like swappable parts. So there's like a Flume container, and this is like the flumeDB. And there's a couple of things you can install. Every flumeDB has to have a log. This is the store. It's an append-only store, which when you append things to the database, it gets stored in there. And then you can optionally install these things called views. So this is going to be the main focus of today. So why do you need a log and views? Well, Flume is an append-only log, and it's append-only logs are super great for peer-to-peer networks. It's because you have these immutable entries in the database. They can't be changed by anyone. The bad side of that is sometimes you kind of would like to edit them or have an edit. The way you can get around this with an immutable data structure is your log collects a bunch of messages about, say, a gathering. Maybe I can pull up an example. This is probably going to... so the gathering that I posted on... just a moment, I'm running too many things. The gathering that I posted advertising this event, it's made up of a bunch of small messages. And each of those can be reduced down so that we only really care about the final state of who's attending and what the time was. We don't really necessarily need to see all of the edits. Could be that I've gone ahead and broken my setup, we'll see. So gatherings is an example of that. So you can see these about messages. This view here is like a synthesis of all of those. And a view is one way of, a view is like a reduced state of that whole log. So, any questions about any of that? Decentralization, good question. I did enter a title. I'm kind of confused by Twitch's interface. I added a title, but it seems to have gone. Intro to flumeDB. Is there a save button? Who knows? I'm going to carry on. Okay, so let's look at this. I was talking about the logs. These are the ways you can store things. We're going to use Flume log offset. This is the recommended way to store your log on a file system to persist it. And these are the different views. We're going to just be looking at Flume view reduce. This is the only one I've played with so far. I might do future sessions on these if I've got any sort of mastery of them in the future. So, go ahead and try and code them. I'm going to kill this. Start from scratch. This is another. Please ask me if you need me to make a bigger font size. Okay, so we need, what do we need to start with? We need flumeDb. We need a Flume log, so all of them are Flume log dash something. So we're going to use offset, and we're going to use Flume view reduce to generate some of those condensed states. So I'm going to jump and look at Flume log offset, because being a file system thing, there's a couple of other configuration settings. So the main one is you need to install a codec, as in, like, do you want to store this as JSON or as binary or whatnot. Oops. Looks like I was here already. So step one, we are just going to try writing things to our database. What do we got? So we want and I think we need a codec as well. Okay, so how does it work? We make a database by taking Flume and instantiating it with a log. In this case, we need to instantiate a log, I think. Let's look at the database. Yeah. So I'm going to break it down on a couple of lines to make it readable. We need to give it a file name. So I'm going to call it demo log, so it stands out really clearly. And we need to give it some options. And the documentation currently says it defaults to JSON by itself, but that's a lie. I'm going to open a pull request later today. Okay, so let's... What do we want to do to that? Okay, now hopefully we can just use the database. So there's a bunch of methods. We'll go and have a look at them in a little bit. but I'm just going to do append message hi. And I think there's a callback. I'll just it takes, because appending to that database is asynchronous. If error, let's throw an error. Okay, so return to 0. We can go and look at what that's about, but we've also got this demo log that's there now, so let's see what's in there. Cool, there's a message in there. Let's run it again. Oh, okay, so we've got this another number 31 back, and we've got 2 messages in there now, the same message twice. Let's try so hopefully there's nothing too surprising about that. So what that data number is it's called the sequence number, and that's the how far along we are in the sequence that message is, like where was it inserted. So in the memory case, this might increment as like 0, 1, 2. Flumelog offset actually inserts, and the sequence or the location of a message is its bytes from the start of the file, which makes looking up entries in this database, if you have the sequence number, incredibly fast, because you know exactly where to read to. Any questions so far? I can't comment on event sourcing and projections. Is it as in flumeDb, or are you talking about Scuttlebutt more generally, decentralization? Craig. Oh, cool. Yeah, maybe it's a computer science term I'm not yet familiar with. The other terms you hear are like materialized view. I think that's what the view is short for. Projection sounds fairly similar. It's kind of like a mapping. It's like a reduce. Okay, so we've got all that set up. Now let's try reading from the database. I actually don't think I've done this. This will be interesting. We don't want that. Let's look at the documentation. So we've got get and append, and we've got stream. So we could do a get, and that would be using a sequence number. I guess let's do that. We happen to have been logging those sequence numbers, so let's just try doing that. db.get and I'm just gonna give it console log as the fallback. Cool. Let's try the stream. What's the API of that? I think it takes just a callback straight off. Oh, no, my bad. It makes a pull stream. So really quick aside on pull streams, they're like node streams but pull based, and we're using a library called pullStream. Scuttlebutt uses the library pullStream extensively. And the way we do things is this. So pull lets you compose a bunch of stream elements and pipe them together. So in this case, that stream method creates what's called a source, and we need at least a sink. So pull also provides a bunch of convenience methods, but there's a whole ecosystem of modules out there. Drain is, unsurprisingly, maybe a type of sink. And I just want to console.log that message. So values will be pulled out of the stream and dumped into here. Burp. Cool, so all of this values are streamed out there. All right, so you'll notice that when you stream it, you get the value and the sequence, which could be useful for looking things up. Say I just wanted to actually just get the text out. You can do a map within a stream. So stream.map. The messages as they're flowing through the stream from the source down to the sink will come through here one at a time. And I just want to return message.value.message. It's a bit ugly. Like that. So that's pretty powerful. You can also do some other fun stuff like you might have seen that on the stream. There's a bunch of options it can take. So less than, greater than or equal to. These would be less than or greater than or equal to a particular sequence, because that's how offset is ordered in this case. Reverse, you can make it go backwards. Limit, you can say give me only 10 of them. Live is probably the most fun. So let's have a look at that. So hopefully the stream will stay open. Okay, it's exited out. How did I demo this in the dry run? Yep, I'm going to cheat and look at it. Doop, doop. Where you watch Mix muddle around with his too many tabs. Believe it or not, this is a fraction of the tabs I'd normally be running. Okay, so I'm not sure why the database closed, or the database connection was closed, but here's an example where I'm appending. You might imagine that these are two different areas of code. So here's a pull values. This is a little bit of a contrived example, but imagine some user is generating data somewhere. Pull values will supply as a source first the value 1, then 2, then 3. These are fed into the stream. Async map this is again contrived. It's a way to like pause for a moment while maybe there's a request made somewhere else, or you're looking up some data. So in this case, I'm just using it to set a timeout so that it slows the stream down so that you can see it coming through. And then finally draining into an append. So in this particular example, maybe I will copy this example in so you don't have to watch me type it. In this particular example, we will see this stream updating in a live way. So like I've used a different file name. Okay, here we go. I've got a bunch of console logs in there to give you a feel of like when different things are happening, but you can see the values. Oh, we've still got these initial values in the database, and we're now appending some more because we're appending in the format of count and the value that's being streamed through, so count 1 and count 2. So that's these being, that's the append happening there, and then this is the other stream, the pull stream, which would maybe be running somewhere else listening, streaming out those values. Any questions on any of that? Let me check. Yeah, correct, Mark. I think that was an error. I think maybe I was quote tweeting, which is not very helpful, but thank you for adding that link. Yep. Pull stream working over sockets. Good question. I don't know off the top of my head. Do you mean socket like WebSocket, I guess? Yep. I think I'm going to put dashes in here so it makes it easy for me to like see where I've read up to when I'm answering questions. Okay, so we've got, we have a pull stream. We're reading and writing to a database. This is not particularly useful. What I want to do is now try and add a view. So I'm actually going to wipe my database, just that log file. And I think I'm going to just comment this out. This is the, I'll leave a note here. This is that's the reading pull stream. And this is the writing. So we want to add a view. So the way that we do that is the flumeDb has a use method, and we declare the name of the view. This is going to be a place that it gets attached. So I'm kind of going to go for the sort of follow the example that's in the documentation. We're going to write our own little stats view. So we've got these, we're appending these counts maybe we want a view that is like the summation of those, or the summation of the square of them, or the mean of them. So so you can attach a number of other view. You can attach a number of views like that. Just give me a moment. I'm gonna try and put the sound barrier between us and Screaming Ziva. Yep. So how do we do that? Well, Flume view takes at least 3 arguments, a version number for the particular view. If the view if this version ever changes, the view is recalculated, scrapped and rebuilt. Makes it really easy to tweak and like refresh the view state. And then it takes a reducer. You can get away without a map, I think. Let's start with just those two. We'll leave them in. So this is how I've been working with them anyway. So write each of these. So the initial is the initial state of the view. Leave some notes as we go. Reducer. So the reducer is a pretty standard reducer. It takes an accumulator and the next message that's come in, or the next entry from the database. So in our case, we want to set out what the state, this view state's going to look like. So the sum is going to start at 0, and I'm going to go square sum of the squares, because that can be useful for statistics. And then the accumulator, so how do we add to that? Well, we return the new accumulator state will be sum is the accumulator sum so far plus the message. It's not going to be quite that, but we'll come back to it. So this is so the messages that are going to be coming through are going to be of this form, count 3. So this is where having like a map can be quite useful. We might not want to pass that whole thing to the reducer. Actually, it'd be nice if I could just pass the values that we're counting, and then this would work a lot more tidily. So for that we need a map. And in this case, our message, we just want to pull out the count from it. So what happens is the map gets run, then that gets passed to the reducer, and then that updates the view. Null, what is null? It's a codec. I don't know why it's in there. I think you can override how the view is stored. So let's try running that and see what I have omitted. A bracket somewhere. Mm-hmm. $18. Maybe someone spotted it. Over here. Nope. Over here as well. Okay, so it did something. We don't have any way to look at the view so far, but we do see a new file called stats.json. And see, it's got the version, the value, and the reduced state, which is not quite correct. That's because I've made a typo here. I probably need to bump the version now because, or change the version because the, you'll notice in the stats.json, there is a sequence number. This is the view keeping track of how many of the messages it's processed, so it doesn't need to reprocess them all every time you start an app up. So anytime there's a new message, it would bump that number. So if I left it at 1, we can put a symbol in like that and watch. Wow. You can watch whether it runs those things. Interesting. Oh, yeah. So it is running those things, and it's because this, every time this write is going to happen over the top. But let's have a look at what we should see is that the summation should be 28, but it won't be. Oh, no, it will be, but for embarrassing reasons. So given how much there is in the database, it should actually be 56 or something like that, because there's now a heap of different counts in the database. You should have one in there twice, yeah. So let's bump that, and I'm also going to delete wipe that database. Great, so now it's working correctly. We want to read things out, so shall I make another file or just pile stuff on? I think I'm going to make another file so that people reading over this can get a sense of how this got built up. So we go have a look at the Flume documentation, because there's similar get methods and stream methods as on the general database. So under Flume view, actually we shouldn't look at the flumeDb, we should look at the Flume view reduce, because I think that's got a good description of the API. So even though Flume view reduce is attached to the flumeDb, what happens is the flumeDb exposes many of the methods in under the view's name. So that is as we attach it at stats or statistics, whatever location we want to name that view as, you can then go db stats get, and it will give you the current state. Or you can do the same streaming trick. There's a little bit of an interesting gotcha here, which I'll come back to. So, wipe that database, and let's set up the reading. No, we'll do an asynchronous read. So in the drain, so drain actually takes two arguments. One of them is, yep, hi, come on. Just give me a moment. I'll just got to do the obligatory baby. Oh, this is a sleepy Ziva, or sleepy Ziva. I'm doing a baby to grandfather transfer. Hey baby. So pull drain takes two arguments. One of them is like a callback which handles incoming values, and the other one's a callback that gets called when the stream ends. So I'm going to chuck something in here. I'm going to put in a db.get, db.stats.get. It's called stats because that's what we call our view. If I change this view to dog roll, this would be dog roll. I wonder if there's an error in a val, we'll see. Let me know if that baby's too loud. I can ask someone to go somewhere else. Okay. Did I wipe all the things? Should I need to? Yeah. So that's a little bit interesting. I think what's happened, so that should be 28 and 140, is that I've put this callback in not the ideal place. What's happened is that the append has happened. You can see the append has happened, but it's because that's asynchronous. It's completed happening, but the view hasn't been updated by the time this stream ends. So the actual place we want this is here. So this will show us the append state. Sorry, the view state. We go. All right, I'm going to pause for some questions. Yeah, I'm not going to pause and talk about pull streams, partly because I don't know too much about it, but also not what I wanted to focus on today. Doggerel, yeah. You can also have a good time with I want my name looking at the domain names with but in them. There's like but.company and stuff. I think but.space is taken, unfortunately. Yeah. Similar to node streams, they're a little bit simpler in their implementation. It's a little bit cleaner, I think. But yeah, I think as you say, back pressure is the main advantage. As in, yeah. Okay, so we've got asynchronous calls, so we can make an asynchronous call on a view, but we can also do a streaming view. This is I'll just make this another file. Let's have a look at what this looks like. This one surprised me quite a lot when I first saw it. I keep running the wrong thing. I don't know why that is throwing that. Stats.source is not a function. It was called stream. So what we're seeing is the view state and then numbers, just 1, 2, 3, 4, 5, 6, 7 coming through. And I thought this was an error initially, because what I would expect to see is a stream of the view, as in this should be like, this one here should be like sum 1 square sum 1 sum 3 square sum 5. When I talked to Dominic about this, his justification was for this sort of inhomogeneity is that this can save a lot of data transfer. So imagine a state where you your view has got to being sort of 1 to 5 megabytes. It's not huge, but you don't really want to be emitting like and sending a 1 or 5 megabyte update, especially if you're sending that to somewhere remote. It's much more efficient to send the person a snapshot of the current state. In our case, this is the initial state, and then send them the mapped values. So these are the 1, 2, 3, 4, 5. And then it's a little bit inconvenient for them because they need to write some more code, but they can then use the reducer with this initial state, as long as they use the same reducer carefully, and recreate what's what the view state would now be up to. So let's try and do that. So I think I wrote, I can't remember if I think I wrote this as an example as a pull request. I don't know if it's merged yet, because it confused me initially. So I'm going to make a variable called view state. The first one coming in, if there isn't already a view state, then view state, set that to be val, and then otherwise the view state will be the reducer run with the current view state and the new value that's just come in. I think that's right. And then let's console.log the view state. So only problem is this isn't named reducer. Thank goodness for parents. Grandparents looking after children. Okay, let's pause and read this. I think it's that the accumulator initial state thing might not be working quite right. Which is weird that you can delete it again and then it just works. I'll come back and look at that sometime. But here you can see now the reducer's getting run twice, which is what we'd expect. It's getting run on the view, and then by this this is more like client code that's streaming and listening to the view changing. And this is the outputted state we'd expect. Let me pause. Cool, no more questions so far. More messages below. All right. So I think that's the basics of Flume View. So what I wanted to transition to, and this is where it might get a little bit bumpy, is looking at how we use Flume View in Scuttlebutt. So I gave the example of gatherings, which I don't think actually uses Flume View yet, but there's a great example is already implemented as a chess game. The chess module for Scuttlebutt, implemented by Happy Zero, uses Flume View. Let's go and have a real quick look at it. So here's Flume Reduce. That's just Flume View Reduce. And it's using that format of index, use function, Flume map function. And then he's returning. So this is now like some of the Scuttlebutt stuff. So here he is building a view, and he's I'm not really sure how to cover this in a really quick way. What we're looking at is the inside of a Scuttlebutt server plugin. So when you start Scuttlebutt, you can say, here, could you use this SBot plugin? And the requirement for like every one of these has a name, a version, an init function, and a manifest. and it's just an object. So the init function is expected, so like let's talk about what the manifest is. The manifest is an object which is like, looks a little bit like this. This is a detailed list of all of the methods that are going to be provided by this plugin. And so you give the method name that will be provided and what sort of function it is. So it can be sync, async, or a source, which is a pull stream. And then init is a function which is given the current, it's given a copy of the Scuttlebutt server and the config, and you're expected to do whatever you want. And then because our manifest has declared that we're going to because we've declared we're going to use a get and a stream, we need to return a get function and a stream function. Woo. And that's, yeah, so they should be as simple as that. I think I had some trouble getting this set up. But let's, now that you've got that context, let's go look at how Happy Zero has implemented that with chess. So what you need to know about SBot is that this is, it's the Scuttlebutt as it's been created, and it's got each of these plugins is attaching methods to that Scuttlebutt. So you need to be careful about some name collision stuff, but we expect if this has got a name like stats again, then my understanding is that other people who get an instance of SBot will then have access to stats, sbot.stats, and there should be a get method under that attached because we've provided one and we said we were going to provide one. Similarly, there'll be a stream method stored in there. So let's go look at that. Let's go look at that over here. Here he's called an SSB. So there's this, here we have the name, the version, a manifest. He's providing a get and a stream function. And he's using the SSB, and SSB already has a method called Flume use attached to it. And this is just a convenience method for attaching Flume views at the moment. So it takes care of wiring up some of the things for you, but it follows a similar pattern to our code before, which is like, let's attach this to about. We're not looking at the chess one, we're looking at SSB about, sorry. About, and here's the reduce. We can look at chess, it's pretty similar. He's got more methods in his manifest and he's doing some slightly fancier things, but let's have a look. Again, he's using Flume use to attach this view to the Scuttlebutt so that it's accessible under SSB chess index. And then he's returning these methods and he's doing things, he's doing further things with the view, further computations, rather than just serving up the straight view. So yeah. Okay. I'm going to pause, see if you've got any other questions. No more questions. Okay, so I might try and do a little bit more code with an example, like just continue with some code that I was working on before this. There's a good chance I'm going to hit some speed bumps, so I guess bear with me. I was having some trouble. So so here what I was doing was taking a minimal setup to run my own custom SBot, and I'm installing a bunch of plugins which are like sort of the standard ones. I haven't looked closely at what these do. I think when I disabled some of them, things didn't work. And then I'm asking it to also require this custom module that I've been working on here. I want to make a view which calculates who my actual friends are, as opposed to, so I'd say my actual friends are the people who I talk to and people who I mention, people who mention me. So we could gather and reduce those stats. That's my server. And then in my client file, which is going to be connecting to that particular server, hopefully, I've got a who am I call just to check that it's connected to the right place. So let's just spin some of this up and see if it works. Oh damn. I think I need to kill my other SBot over here. Node server.js. So, well, okay. Maybe it's working better than it was before. So, what was it logging out? It's logging out that it's starting the server, and it's also logging out I think I logged out some other things in my module that I've been writing, so yeah, we'll come back to that. No, let's look at it. So here's me trying to start writing a plugin. I'm calling it actual friends. I've given it a version. I don't know if that needs to be a string or a number, or if it's causing trouble. Got a manifest, which is get and stream. I want to provide those methods. I've got an init. And in here, I've copied the pattern which SSB chess laid out, which is let's make a view using this convenience method, this flume views. And we are seeing this here because I've console logged out the view. Yeah, that's the Flume view initializing. So there are actually several methods being returned, but I think the manifest will only make get and stream accessible, hopefully. So the SBot is up and running. I think the trouble I was hitting was with this client code. So I've already done I did a previous stream on the SSB client. That'll be in the Scuttlebutt guide. There's already a link to that in the Scuttlebutt guide, which is, if you just joined this call, the thing with the Earthsea map. Oh, damn. Scuttlebutt guide. This one. I'll post a link to that again in case you just joined us. So, yep, there's a tutorial for this. It's got a Git repo and a recording of the string. So client.js file. Okay. So here it is logging out this who am I. This is my identity. I just know it because I've seen it before. And we're also logging out what are the methods that are on the SSB server. We're seeing that there's a bunch that are already set up. Friends. So this is the bit that was tripping me and that I was confused by, is that when I set up this particular server, I haven't told it to include the SSB Friends plugin, so I don't know how this is getting in here. Same with blobs, how's that getting in here? Backlinks in private, full text, WebSocket, none of these should be enabled. I have a suspicion that I'm loading a config which is by default loading my plugins, because in your SSB folder there is a config file, and it has all of these things. This is from me doing some dev work, so I think I'm accidentally picking up these settings, which is a little bit annoying. I'm not sure how to disable that. Regardless of that, it should be installing this SSB server actual friends, which I think should be adding an actual friends to this object, but it's not. Prove that. Actual friends methods. So I think that's about as far as we can go for the moment. I think I might come back and cover this in another video once I've figured out what I've done wrong with my setup. Unless anyone would like to help me debug it. Does anyone have any questions or any feedback on what we've covered? All right, I'm gonna hang out. I'm gonna stop recording, but I'll hang out here. Please feel free to keep lurking and asking questions, but otherwise check out the repo, which is Flume intro, over this afternoon. I hope to post up the video. Yeah, have a great day, everyone.